When the first computers appeared, they allowed us to count the uncountable. When the cloud emerged, it dissolved the boundaries of distance. Now, quantum computing promises to dissolve the boundary of certainty itself. In the corridors of Microsoft's Azure division, engineers speak of a quantum classical hybrid cloud, a living fabric that shifts workload between GPUs, CPUs, and quantum processors. The idea is not to replace classical systems, but to orchestrate them, to weave the physical and the probabilistic together. IBM calls its vision the roadmap to fault tolerance. Each new generation of its machines pushes error rates lower, coherence times longer, building toward a moment when quantum computers will run for hours without drifting into noise. Every step forward is shared through IBM quantum data centers, connected across the planet like neural nodes of a single colossal brain. And then there are the smaller pioneers companies, such as Microcloud Hologram Inc., whose engineers have refined algorithms once thought purely theoretical. Their improved version of Grover's search algorithm performs dynamic multi-mode searches using up to 22 qubits on a single FPGA platform. They have modeled scalability up to 32, proving that hardware limitations are no longer the only bottleneck. The bottleneck now is imagination. The rise of the quantum cloud is doing something unexpected. It is democratizing discovery. A decade ago, the phrase quantum supremacy belonged to research papers and academic rivalries. Today, high school students can run Today, high school students can run entanglement experiments through web interfaces. Developers download quantum SDKs as casually as they once imported machine learning libraries. Innovation is no longer gated by hardware. It flows through APIs and curiosity. Yet, with every door that opens, another question follows. What happens to security in a world that can break encryption? The algorithms that protect our data, RSA, ECC, all those elegant mathematical logs were designed for classical computers. Quantum machines threaten to pick them like paper. Experts call this the cryptographic cliff. When a sufficiently powerful quantum processor becomes reality, much of today's encryption will fail. To counter it,